So let's do an example of equal proportions. So say employers want to know which of the days of the week employees are absent in a 5-day work week. Most employers would like to believe that the employees are equally absent during the week. That means that, they're sick different, the same proportions, or they're not skipping out Mondays and Fridays. Suppose a randomly sample of 60 managers were asked of which day of the week they had the highest number of employee absences. The results were distributed on the next slide. For the proportion of employees, do the days for the highest number of absences occur with equal frequency during a 5-day work week? Test the 5% level of significance. So here's the results we got. Remember, they asked 60 managers to pick the day that the most absences occur. So on Monday there were 15, Tuesday there were 12, Wednesday there were 9, Thursday there were 9, and Friday there were 15. So these are my observed amounts. This is what the managers observed. So now I need to make my null and alternative hypothesis. So the problem wanted us to know for the population of employees, do the days for the highest number of absences occur with equal frequencies? So I'm just going to write my null as the proportion of all the categories are all the same, since I'm saying there is no difference in the number of absences based on weekday. My alternative is the proportions of all the categories are not the same. You could have used the other choices that we talked about with equal proportions, but these above to me are easier to understand. Okay, so I'm going to show you how it's solved by hand, but please don't solve it by hand. All right, to find the expected values. Remember I said that the manager said there were 60 managers that reported. I added up all my observed values and I got 60. And I divided 60 by 5 since there were 5 categories. So my expected number of absences for the week, if they're all the same, is 12 absences per day. So again, my observed is what the manager saw. The expected is the observed added up divided by the number of categories. So then I'm going to keep going with that formula we saw before, and I'm going to do the observed minus the expected. And as you see here, it just gives me some numbers, and then I square them, and then I divide by the expected. And then when I add all these up together, I get the chi-square test statistic. You're never going to have to do this by hand. We just wanted you to see what it looked like when it came together. So the chi-square test statistic is 3. So my degrees of freedom is 4 because 5 minus 1. Remember, I had 5 categories minus 1. There is a way in the calculator to get the p-value, but I really want you guys to use the website. I think it's so much easier. But in the calculator, if you ever want to find it, you push second distribution, arrow down to chi-squared CDF, and you hit enter. And then you have to do 3, which is your test statistic, comma, positive infinity, and then the degrees of freedom is 4. And then you get 0.557H, which is the p-value. So since 0.5578 is greater than the level of significance, you do not reject your null hypothesis, or you fail to reject it. But what does it mean? So if you don't reject the null, it means you found the null to be true. So we need to conclude it properly. At the 5% level of significance, there is not sufficient evidence to conclude that the absent days do not occur with equal frequencies. So, what does that mean to you? It's a really hard way to say this because if you see there's 2 knots in here, and that's kind of crazy. So think of it this way. You could also say it this way. At the 5% level of significance, the absent days of the weeks occur with equal frequencies. You just have to be careful how you conclude these because sometimes it can lead you to different ways. So again, based on what they were, even though the days look different, when I averaged everything together, there was no difference in them. So you could go back and tell the managers, even though you feel like there's differences in the days, there's not.